Hello everyone. Today we're going to be going over our Chapter 7 review for Exam 2. So in addition to the problems gone over in our review, it's also going to be helpful to review some of these items below on your own, as well as the problems that we're going to go over today. Alright, so for Section 1, we want to focus on finding the exact values of an inverse trig function, finding the exact values of composite trig functions, and then solving equations involving inverse trig functions. So we're really just working with these different inverse trig functions and then solving equations that are actually going to contain them. Then Section 2, we want to find the exact values of inverse trig functions again. So just to make a note of this, in Section 7.1, when we talk about finding exact values of inverse trig functions, that's going to be sine, cosine, tangent. For Section 7.2, with the finding exact values of inverse trig functions, that's going to be with secant, cosecant, and cotangent. Then we want to focus on writing trigonometric expressions as algebraic expressions. So remember, that's taking our trig functions, rewriting them into their algebraic forms, and then being able to finally write it in some sort of algebraic way, most often going to be of one variable, maybe some other numbers as well. Then finding exact values of mixed composite trig functions as well. So that's still going to be with your composite trig functions. They are just varied. So you can have a mixture of them. Section 7.3, we want to find approximate solutions to trig functions. So that would be using a calculator. Whenever you're asked to find approximate, that's going to be calculator. Solving trig equations with more than one trig expression, so multiple trig expressions then. Finding solutions to trig equations in the interval 0 to 2 pi. So then that would be finding the solutions in just the interval 0 to 2 pi, so that's when you're going to be dealing with your solution sets. Section 7.4, we're establishing our trig identities. So this is when we have a statement or an equation set up and you want to follow along to try and end up with the goal part of your equation starting from a specific point. So establishing a useful identity that you can use in the future. Section 7.5, we want to use sum and difference formulas to solve for exact trig expressions. So everything is basically a review now. We're just also including the sum and difference formulas included within everything that we've gone over so far. And lastly, Section 7.6, we want to be identifying properties of double and half angle formulas. So this is just recognizing what they look like and recognizing their formations when you write them out. So the exact formulas specifically. And then we want to use our double and half angle formulas to find exact values and also to establish identities. So using those half angle and double angle formulas help us establish certain identities, and also we can use them to find exact values. All right, so let's move on to our first problem here. So our first problem, which is from section 7.1, we want to find the exact value of the expression tangent inverse of tangent of 8 pi over 9. So 8 pi over 9 is not a value that's given to us on the unit circle. So one, we're going to have to find the exact value of tangent of 8 pi over 9. And we're going to have to use this composite tangent function as well. So let's get started here. We'll use another color, or we'll use green. So what we have here is that we have tangent inverse of tangent of 8 pi over 9. We have already established the properties that state that if you take a function f of x and you take f inverse of f of x, or if you take f of f inverse, then or f inverse of x, then essentially you will end up with the value of x. The only thing that changes about x is its domain in that case. So we want to use this property. So we want to use the property f inverse of f of x is equal to x with tangent. So we have tangent inverse Sorry about that, my screen was wigging out momentarily there. But we have tangent inverse of tangent of 8 pi over 9. And what that's telling us is that this is going to be equal, or if we replace our 8 pi over 9 instead with x, this is going to be equal to x, where x has to be in between negative pi over 2 and positive pi over 2. But if we realize 8 pi over 9 is not in that interval, so we have to have x in the interval negative pi over 2 to pi over 2, with 8 pi over 9 is not. So since we know that 8 pi over 9 is not going to be in this interval, we have to find an angle that is. So if we want to do that, we have to find the reference angle. So we have to find the reference angle for 8 pi over 9, such that tangent of 8 pi over 9 is equal to tangent of theta. So some reference angle theta for theta in the interval. All right. So we know what we have to do now. There's a few other things that we can specify going forward. So we'll make a little note right here. So we can determine what quadrant 8 pi over 9 is in. And we can determine this very easily. We see 8 pi over 9, that's going to be less than pi, just pi itself. It's greater than pi over 2, which means that it has to be in quadrant 2. So we can determine what quadrant 8 pi over 9 is in by deduction. So it's in quadrant 2. Quadrant 2. Okay. So it's in quadrant 2. In quadrant 2, we know this is where cosine or x is negative, sine or y is positive. So we know our original angle is going to be in quadrant 2. Our reference angle needs to be in quadrant 1. So say our reference angle should be in the interval negative pi over 2 to pi over 2. So best if we can get in quadrant 1 if we're talking about our unit circle, but anything in this interval is going to be useful. So our reference angle should be in the interval negative pi over 2 to pi over 2. So how we're going to find this reference angle is we are going to subtract 8 pi over 9 by pi. We're going to subtract this from pi. So we're going to say theta is equal to pi minus 8 pi over 9, which pi can just simplify to 9 pi over 9 minus 8 pi over 9, which leaves us with pi over 9. So our reference angle is going to be pi over 9. So Another thing that we need to realize, since we found that our 8 pi over 9 was going to be in quadrant 2, doesn't mean that tangent of 8 pi over 9 would have to be negative. So since 8 pi over 9 is in quadrant 2, this means that tangent of 8 pi over 9 is negative. So if tangent of 8 pi over 9 is going to be negative, and we know that pi over 9 is in between negative pi over 2 and pi over 2, 8 pi over 9, we also can recognize this is going to be in quadrant 1. Since tangent is positive in quadrant 1 but negative in quadrant 2, we have to allow our reference angle to be negative. So this means that tangent of pi over 9 must be negative as well. So if we're saying that tangent of pi over 9 must be negative as well, we're actually going to introduce this negative straight to pi over 9. So now we're going to have negative pi over 9 instead of positive pi over 9. And we just do this so we avoid using the negative inside of our composite function. So it's very straightforward in using our formula. So when we say that we're going to make this negative, then it's really going to be tangent of 8 pi over 9 is equal to tangent of negative pi over 9. And we know negative pi over 9 is still in the interval negative pi over 2 to pi over 2. So this all checks out with using our new reference angle of negative pi over 9. So we've edited our previous reference angle to match what we need. So we have tangent of negative pi over 9. Now we can use the formula. And remember, our formula from the beginning here states that f inverse of f of x is equal to x, or in other words, with tangent inverse of tangent of x is equal to x, where x has to be in the interval from negative pi over 2 to pi over 2. Everything we have is checked out and correct. So now we can use our formula. So we'll say that tangent inverse of tangent of 8 pi over 9 is going to be equal to tangent inverse of tangent of negative pi over 9, which is now just equal to negative pi over 9. And this here would be our final answer then. So if you were given this answer, or if you were given this question initially, and whatever you had in your parentheses that was acting as x in this case was contained in the correct interval, then you could just use the formula and there would be no rewriting or anything like that. But since our value of x in this case did not fall in the correct interval, we then had to find a reference angle, and then we had to make sure that they were actually going to be equal to each other. So those are the steps that we had to take if we were not given an angle that fit in our interval.